Yes, welcome to the continuation of more examples on the differentiation of inverse trigonometrical functions. Now we also have this other question too that follows our question 1 in the previous episode, and it says given that y equals sine inverse of this function, show that dy dx is that. So we shall quickly begin by saying that if y is equals to sine inverse of 1 minus x squared out of 1 plus x squared, then it implies that sine of y is equals to 1 minus x squared out of 1 plus x squared. So if that is true, we're now going to differentiate the left hand side and the right hand side with respect to x. Now on the left hand side, automatically we shall get cos of y dy dx, which is going to be equals to, now the right hand side we are going to differentiate it using the quotient rule, and that is going to be giving us 1 plus x squared as our v. We differentiate the numerator, shall get minus 2x minus 1 minus x squared as our u. Then we differentiate the denominator to give us 2x. All this divided by 1 plus x squared, but all squared. Then we can now do the simplification on the right hand side, so that we have cos y dy dx is going to be the same as minus 2x, I'm opening the brackets, minus 2x cubed, minus 2x cubed, then minus 2x again, minus 2x again, then plus 2x cubed. All this divided by 1 plus x squared, but squared. So if that is true, then we can realize that this and this can cancel, so that we have cos of y dy dx is equals to minus 4x divided by 1 plus x squared, but all squared. Now from this point, we can now think about cos y. Remember, I can use the first identity of trigonometry, where cos squared y plus sine squared y is equals to 1. So it means cos y alone will be the square root of 1 minus sine squared of y. All this dy dx giving us minus 4x out of 1 plus x squared, but also squared. Then when we get back here, we're going to do the substitution. Remember, sine y is the whole of this, so it means I'm now going to have my square root into 1 minus x squared out of 1 plus x squared, but all this squared. Remember to have that all into dy dx is equals to minus 4x divided by 1 plus x squared, but squared. So now from this level, we are going to simplify whatever we have inside the square root here. Then we can see where it leads us. Okay, so now we are going to have both the numerator and the denominator squared here, but that will give us the LCM as 1 plus x squared, but squared. Then it means we shall now have here 1 plus x squared, but squared again. Then minus into brackets, you can extend that. Into brackets 1 minus x squared, but also squared. Remember, all this is under square root. That is why my square root is long enough to cover everything. Then dy dx is equals to minus 4x divided by 1 plus x squared, but squared. So now when we look at the numerator, you either use the difference of two squares, or you can simply do the expansion. I will use the easiest way, that is difference of two squares, and so it means I'm going to simply add and subtract. So when I add this plus this, I realize that x squared will cancel. So it means I will have a 2. So it means the square root now is going to have a 2 into brackets. When I subtract this from this, it will be giving us a situation whereby the 1 will cancel, but x squared minus x squared will give us 2x squared. All this, of course, divided by 1 plus x squared, but squared, dy dx, and that gives us a minus 4x out of 1 plus x squared, but squared. And when you look at this critically, 2 by 2 is 4, so it means we're going to have 4x squared, but the square root of 4x squared is actually going to be 2x. Then the square root of 1 plus x squared but squared will be 1 plus x squared. So all these multiplied by dy dx will be giving us minus 4x out of 1 plus x squared but squared. And when you look back, you're going to realize that the 2 can reduce the 4 to 2. The x can cancel with this x. This denominator here can reduce this denominator to 1 plus x squared. So it means ideally that dy dx is going to be negative 2 out of 1 plus x squared, and that is the answer as it was required in our question. So you can see we have done it quite easily. Let us look at some questions now that will also make us try out and make sure we perfect on this. Okay, so these are our simple trial questions. I've again made them in such a way that the answers are actually provided. They're all proofs, so you will either know that you've passed, or maybe something went wrong somewhere for you to easily go back and rectify it. Please, thank you for following. Share this video, like, and make sure you subscribe so that we can build this system stronger and stronger for this nation and even the world at large. See you again in the next episode for derivatives of exponential functions and logarithmic functions. Bye-bye.